Okay. So yesterday we are discuss about multiplicative inverse and additive inverse. Here what is additive inverse? Additive inverse అంటే ఏంటి? Additive inverse. Additive inverse. So whenever a plus b is congruent modulo of 0 mod n. This is the formula for additive inverse. Whereas in multiplicative inverse, a into b is congruent modulo of 1 mod n. So this is the formulas for additive inverse and multiplicative inverse. Here b is additive inverse of a. Here b is multiplicative inverse of b is multiplicative inverse of a. So ఎలా క్యాలిక్యులేట్ చేస్తాము అంటే a plus b mod n is equal to 0 అవ్వాలి. Same way a into b mod n equal to 1. At that cases only b is additive inverse of a and b is additive inverse of b, multiplicative inverse of a. So this is the fundamental concept about additive inverse and multiplicative inverse. So here we are going to see what are the addition and multiplication tables to easily find out the inverse values. So here the z value is 10. So here the z value is 10. That means n is 10. So z value is 10. That meaning is n value is 10. So what are the elements in z set? That is equal to 0 to n minus 1. That's why the table is taken as starts from 0 to and ends with 9. So here also 0 to 9. So while calculating addition table, first we need to add the element in this row and the element in this column. So here 0 is added to 0. So what is the formula for additive inverse? A plus b mod n. So here in this case, the rows indicates a value and column indicates b value. So here 0 plus 0, that is 0, mod n value is 10. So that is 0. Next, if we are going to fill this value, then a value is 1 and b value is 7. 1 plus 7 is 8. 8 mod 10 is equal to 8. That's why here we are putting 8. The same way the entire table will be filled. So table మొత్తాన్ని మనం అలా fill చేయాలి. So whenever you got the value 0, those elements are in the set additive inverse table. So those elements are in additive inverse set. So here what are the values in Z10 or additive inverse? So additive inverse లో ఉన్న elements. So which elements will have the value 0? So here 0 and 0. 0th row, 0th column. That is the value. So that is one set is 0, 0 and another set 1, 9. 1, 9. Then 2, 8. Then 3, 7. 4, 6. 5, 5. 6, 4. And so on. So whenever we will get the value 0 as the addition plus modulus operation performed value, those intersection of rows and columns are taken as additive inverses. So here almost all the elements are covered in additive inverse. So that's why the Z10 additive inverse set contains all the elements. So here each and every row at any place, the 0 will be obtained. That's why every element will have an additive inverse with another element. So here if I are taken the value 6, Then 6 plus 4 mod 10 obtains 0. So 4 is additive inverse of 6. This is one statement and vice versa. 6 is additive inverse of 4. 6 is additive inverse of 4. అలా మనం additive inverses are calculated with the help of this table. Same way here, multiplicative inverses. What is the formula? Multiplicative inverse formula is A into B mod n is equal to 1. So here also Z value is 10. That's why we will take the row values from 0 to 9 and column values also 0 to 9. So whenever you are going to calculate, suppose this value, so how to perform the calculation? Here A is equal to 2 and B is equal to 7. So what is the value of A into B? 2 into 7, that is 14. After that we will calculate the mod operation. 4 mod 10, that is 4. So the value is 4. Okay. Which cell contains the value 1? Those are multiplicative inverses of 1 each other. So here the combination 1 comma 1 and another combination is 3 comma 7 and another combination is 7 comma 3. Last one is 9 comma 9. So what are the elements? 1, 3, 7, 9. These are the multiplicative inverse of Z10. The elements which satisfies multiplicative inverse are 1, 3, 7 and 9. So in this way we are going to prepare the addition and multiplication tables. So is there any doubt how to prepare addition table or how to prepare multiplication table? చెప్పండి అమ్మ.
No doubts, ma'am.
No doubt. Okay. Okay. So here there is Zn. Zn indicates additive inverses. Zn star indicates multiplicative inverses. Zn indicates additive inverses. Zn star indicates multiplicative inverses. So how to calculate additive inverse? Here Z10 we are already seen in this previous example. So all the elements, so each and every row will have a 0. So that's why all the elements are in the set additive inverse. Okay. So here all the elements are in additive inverse. So when we take multiplicative inverse, Z10 star contains only 4 elements are multiplicative inverse formula are satisfied. So that's why 1, 3, 7, 9 are in Z10 set. So all of you calculate what are the elements are existed in Z6 star. 6 star indicates itself we are going to calculate multiplicative inverse. Here the what is the value of n? n value anta మనం ఇక్కడ ఏం క్యాలిక్యులేట్ చేయాలనుకుంటున్నాం? Z6 స్టార్ ఏమేమి ఎలిమెంట్స్ ఉంటాయి అనేది తెలియాలి. సో n is equal 6. That's why we will take a table and it will contains the value 0, 1, 2, 3, 4 and 5. Here also 0, 1, 2, 3, 4 and 5. So all of you fill these values and which elements satisfies the multiplicative inverse condition. Okay. Only 2 minutes time is there. Perform the calculations quickly. ఎలా చేయాలో అర్థమైందా? So we don't want to calculate the first row because 0 into 0, that is 0. 0 into 1, 0 mod 6, 0. So all the values whenever you are multiplied with 0 will become 0. So we don't calculate the first row, first column values. So after that 1 into 1, this is less than 6. That's why the mod value also the same value. 1 into 1 is 1. 1 into 2, 2. 2 mod 6 is 2. 3, 4 and 5. The values are same. So here we will get 1. So one set is 1 comma 1. Then second row, 2 ones 2, 2 twos 4, 2 threes 6. 6 mod 6, that is 0. 2 fours 8, that is 2. 2 fives 10, 4. So the starting class of modular arithmetic, I am already told to you, whenever you got the value 0, the set will continues from a certain point. So here we will get 0, the value starts from something. Here also after 0, the value maybe starts from some point of value. So here we are going to fill the value 3. 3 into 1, 3. Whenever you got the value that is less than the n value, the value should be same. Because whenever you will divide 3 with 6, the remainder value is 3. So no need to again calculate. 3 to 6. So 0, 9, that is 3, 12, 0, 3 5 is 15, that is 3. So 4 ones 4, 4 twos 8, 2, 4 threes 12, 4 fours 16, 4 fives 20, that is 2. So first we will calculate the product value. After that we will apply mod operation with 6. That is the formula. So 5 ones 5, 5 twos 10, 10 mod 6 is 4, 15, 3, 20, 2, 25, 1. So here also we will get the value 1. So the another set is 5 comma 5. So what are the distinct elements? 1 comma 5. So Z6 star we will write as 1 comma 5. Okay, are you understand the process?
Yes, ma'am.
Okay. Okay. So here Z6 is equal to 1 comma 5. Same way we will calculate Z7 star also. So whenever it is for additive inverse, don't bother about the calculation. The values will be 0 to n minus 1. But multiplicative inverse we need to calculate. Okay, మనం ఇక్కడ calculate చేయాలి multiplicative inverses ని. ఓకేనా? So this is the different sets. Okay. Next one, in cryptography, 2 more sets are there. So those 2 sets are ZP and ZP star. The other 2 sets are ZP and ZP star. So here what is the difference between Zn and ZP are, here in Zn set the n value may be any positive integer. The n value is any integer in case of Zn. So n value is any integer. But here ZP, here ZP and ZP star are another 2 more sets which are in cryptography. Here ZP means the p value should be a prime number. P value should be a prime number. Remaining process is the same. Only the p value, if the p value is a prime number, sorry, n value is a prime number, that set is said to be ZP. Remaining process is same. Zn. What are the elements in Zn? Starts with 0, ends with n minus 1. There is no difference between Zn and Zp except n value is a prime number, then that set is said to be Zp. The same thing is applicable for multiplicative inverse set also. Here also n value is 13. So 13 is a prime number. 13 is a prime number. That's why this set is known as Zp star. Instead of Zn star, the set is Zp star. Okay, here also the values. Here the values are 1 to p minus 1. Instead of writing the formula 1 to n minus 1, we are going to write the formula 1 to p minus 1. So that is, these are the two more sets which are available in cryptography. So this is the second one. So first one is integer arithmetic. Okay, second concept is modular arithmetic. So then we will move to matrices. So the next concept is matrices. So here we are going to cover what is a matrix and what are the operations performed on a matrix, how to calculate determinant, and what is meant by residue matrices and how to calculate those residue matrices. So these are the concepts covered by this topic. So this is the first one. So here this is the matrix. Here it is the name of the matrix, and this matrix contains number of rows and number of columns. So here this matrix contains L rows and M columns. So here the first one is the row number and the second one is the column number. Here the first one is row number, second one is column number. A is element. A is element. So here A11 indicates the element which is existed in first row, first column. And here A12 indicates the element existed in first row, second column, and so on. So here each and every element is indicated as A of ij. That means first one is row, second index is column. So this is the element. This is the element. Here this is a matrix. A matrix is in the form of rectangular form and it will contains m number of rows, or m by n means m rows, n columns. That is size of the matrix. Here this is the definition, and some types of matrices are, first one is row matrix. What is meant by row matrix? If any matrix, it will contains a single row. It will contains a single row. That matrix is said to be row matrix. Okay, that matrix is said to be row matrix. If a matrix contains a single column, that matrix is said to be column matrix. A matrix ni column matrix antam. If a matrix is having the same number of rows and same number of columns, and row column is exactly equal to the column size. Row size is exactly equal to the column size. Here we will take an example. First row, second row, third row, and also 3 columns are there. So here what are the number of rows? 3. And what are the number of columns? That is also 3. So whenever the number of rows and number of columns are equal, then that matrix is said to be square matrix. Then matrix is said to be square matrix. Okay na? Ma, is it clear?
Yes, ma'am.
Okay. Okay. Here this matrix contains all the zeros. All the zeros. Each and every element is a zero. then this matrix is said to be additive matrix. Additive matrix. Okay. So if any matrix contains diagonal ones and upper values to that diagonal are 0 and lower values to the diagonal is 0, that matrix is said to be identity matrix. Identity matrix. So if you take a 3 by 3 matrix, then 1 0 0 0 1 0 0 0 1. This is the identity matrix. So all the main diagonal values are 1 and the upper values to the diagonal are also should be 0 and lower value should be 0. A matrix which contains only zeros and ones, all the ones are in main diagonal and all upper values and lower values are 0. That matrix is said to be identity matrix. ఆ matrix ని మనం identity matrix అని చెప్తాం. ఓకేనమ్మా, క్లియరా?
Yes,
That
ma'am.
matrix is said to be identity matrix. So here the types of matrices are row matrix, column matrix, square matrix, additive matrix and identity matrix. These are the 5 types of matrices. Okay, next. These are the operations performed on the matrices. First one is equality, second one is addition and subtraction. Addition and subtraction. Both of these two operations are going to performed on matrices. And third one is multiplication, fourth one is the scalar multiplication. So here equality means each and every element in a particular position is equal to the each and every element in the second matrix. Suppose if you take a matrix A, the values are 1, 2, 3 and 4. Then B. It also contains 1, 2, 3, 4. So here this is A of 1, 1. A of 1, 1 is 1. Then B of 1, 1 is also 1. Same way 1, 2 is 2. B of 1, 2 is 2. 1, 3 is 3. Sorry, 2, 1 is 3. Here also 3. This is 4. Here also 4. Then A and B are equal matrix. Equal matrices. So even though elements are the same, but the order is not same, then it is not an equal matrices. Suppose if B is equal in the form of 4, 1, 3, 2. All the elements in A and all the elements in B, we will see it is an individually. All the elements are equal, but their position is not the same. That's why here in this case A and B are not equal matrices. So positions are also should be same. That is the equality operator. That is the equality operator. Okay, next one. We will move to addition and subtraction operations. Addition and subtraction operations. So here also we will take two arrays. Two matrices. Two matrices. So here the element in the first matrix is added to the element in the second matrix. So this is A of 1, 1. B of 1, 1. If you want to get the element value in C11, we will add the first element and here first element. That is 5 plus 7. That is 12. In the same way, the second element is added to this place. That is 4. And the third element 1 plus 3. That is 4. 3 plus 8. 11. 10 plus 2. 12. 20 plus 10. 30. So here C is equal to A plus B. This is addition operation. There is no rule. for addition, and here also subtraction a minus b. So the first element, the element in the first matrix is subtracted from the element in the second matrix, we will get the resultant matrix. Here 5 minus 7, that is minus 2, 2 minus 2, that is 0, 1 minus 3, that is minus 2. Here 3 minus 8, that is minus 5, 2 minus 10, minus 8, 10 minus 20. So here minus 20, here minus 20, 10 minus 20, that is minus 20. So this is the subtraction operation. So next one, we will move to multiplication. 1 minute, amma. Okay, ma. Next we will move to multiplication operation. So here whenever you are going to do multiplication, what is the rule? Multiplication operation cheyalante rule enti? Ma vinipistunda?
First row, column. First row, first matrix, first row of second column of second matrix multiply చేయాలి.
దానికంటే ముందు రూల్ ఏంటి? In some cases the multiplication of two matrices are not possible. What are those cases?
M not equal. N not equal.
The number of columns in first matrix should be equal to number of rows in second matrix. That is the condition. So if this condition is satisfied, then only we will move to we are able to calculate the product operation. So the number of rows in first matrix, number of columns in first matrix should be equal to number of rows in second matrix. That is, the size of first matrix is m by n, then the size of second matrix should be n by p. So here both of these two n's are equal, then only the product operation we are going to perform. So what is the size of product matrix? If the rule is satisfied, then we will get product matrix. What is the size of that product matrix? Either m by n or n by p or something else. అడిగిన క్వశ్చన్ అర్థమైందమ్మా?
M by P.
M by P. So the size of product matrix is m by p. So here we will take an example. What is the size of A? Before going to calculate matrix product operation, we will check whether it is compatible to matrix product operation or not. So first we will check the size of matrix A. So here the size of A is 1 row and 3 columns. That is size of A. What is size of B? 1, 2, 3. 3 rows, 1 column. So the first condition is the number of columns in first matrix should be equal to the number of rows in second matrix. So this condition is satisfied. So we are able to perform product operation. So after completing product operation, we will get a product matrix. So what is the size of product matrix? Here also P by M by P. This is the size of product matrix. That is number of rows in first matrix and number of columns in second matrix. This is the size of the matrix. So here we will get 1 by 1 matrix. This is the answer. 1 row, 1 column. So how to perform matrix product. So here first row is multiplied by first column. Each and every element, first row, first column. So first element is multiplied by first column's element, and second element is multiplied by second row. Third column is multiplied by third row. All of the individual multiplications are summed. Addition operation is performed among all the multiplication operations. So here first 5 into 7, that is 5 into 7, then 2 into 8, after that 1 into 2. So 5 into 7 is 35, plus 2 into 8 is 16, 1 into 2 is 2. So what is the value? 35 plus 16, 51. 51 plus 2, 53. So this is the resultant matrix. The resultant matrix అవుతుంది. So one row, it will contains one row and one column. So this is the formula. So next. So this is the multiplication operation performed on somewhat number of rows and number of columns are large number or more than one. So here what is the size of A? Size of A, 2 rows,
2 into 3.
3 columns. And what is the size of B?
3 into 4.
3 rows, 4 columns. So the first condition is the number of columns in first matrix should be equal to number of rows in second matrix. So whenever this condition is satisfied, then we will move to calculation part. So ఈ condition satisfy అయింది కాబట్టి then we will calculate product. So after calculating product, the size of the matrix should be 2 by 4. This is the product matrix size. The resultant matrix will contain 2 rows and 4 columns. This is the resultant matrix. It contains 2 rows and 4 columns. So how to calculate first one? How to obtain this element? ఎలా చేయొచ్చు ఈ ఎలిమెంట్?
5 into 7 plus 2 into 8
First
plus
row,
1 into 1.
ఫస్ట్ రో ఫస్ట్ కాలం అంటే ఎట్లా 5 into 5 into చెప్పాలి
7.
5 into నెక్స్ట్
Plus 2 into 8.
2 into 8.
2 into 8.
నెక్స్ట్
1 into plus
1 into 1. So 35 plus 16 plus 1. That is
52.
52. So this is the value. సరే ఇది రావాలి 18. 18 ఎలా వస్తుంది? This is the second value. So first row is multiplied with second column. So 5 into 3
ఓరేటి మా నువ్వు దండం పెడతాం
plus 2 into 0 plus 1 into 3. 15 plus 0 plus 3. That is 18. Okay na? Come on. Did you complete the remaining calculation?
Yes, ma'am.
Okay. Then we will move to next one. So note down the problem and calculate. Okay, just note down the problem. What are the A and what are the elements in B? Then calculate. నోట్ చేసుకున్నారా?
Yes, ma'am.
Okay. 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 Next one, scalar multiplication. So what is meant by scalar multiplication? So if a matrix is multiplied by an integer value, so n is an integer, then we will get the resultant matrix. The resultant matrix is said to be scalar matrix. So scalar matrix is said to be a matrix which is multiplied by another integer. So here A is a general matrix. All the elements, each and every individual element is get multiplied by an integer. Then we will get another matrix. This matrix is said to be scalar matrix. Scalar matrix. So here 5 is multiplied by 3. We will get 15. 2 is multiplied by 3. 6. 1 is multiplied by 3. 3. 3 is multiplied by 3. 2 is multiplied by 3. And 4 is multiplied by 3. 12. So this matrix is said to be scalar matrix. In general multiplication, one matrix is multiplied by another matrix. At that case, we will check for so many rules. So here there is no rules and regulations. A matrix is multiplied by an integer. Then we will get a matrix. That matrix is said to be scalar matrix. So here the input is one matrix and one integer. And one integer. These two are taken as inputs, and the output is produced a single matrix that is called as scalar matrix. Okay, clear? General multiplication, scalar multiplication differences. In general multiplication, A, B, two matrices input గా తీసుకుంటుంది, output is a matrix. But here in scalar multiplication, A and N, one matrix and one integer. These two are taken as input and it will produce as one matrix as output. This matrix is said to be scalar matrix. In this case, B is said to be scalar matrix, and general multiplication case, C is said to be product matrix. So these are the operations performed on matrices. Okay, any doubts?
No, ma'am.
No, ma'am.
Okay. Okay, next one, determinant. So here the determinants are defined only for the square matrices. What is meant by square matrix? The number of rows and number of columns. రెండు కూడా size equal గా ఉండాలి. So that matrix is said to be square matrix. Here we are going to calculate the determinant of a square matrix. This is the formula. This is the formula. ఇంత ఫార్ములా మనం గుర్తుపెట్టుకునే కంటే the simple method is AD minus BC. AD minus BC. This is the formula for calculating determinant. So ఇక్కడ చూడండి. So this value is obtained by substituting the values in the formula. అంత ఫార్ములా మనం గుర్తుపెట్టుకునే బదులు for calculating determinant value, we will calculate AD minus BC. So here this is A, this is B, this is C, this is D. How to calculate the determinant? AD minus BC. So here this is AD. That means 5 into 4 minus BC 2 into 3. 20 minus 6, that is 14. This is the formula. Okay, in any way we will calculate by substituting the formula, or the simply we will follow this one, AD minus BC. This is the simple one. So AD minus BC, the values finally we will get as 14. So this is in case of 2 by 2 matrices. But we are going to calculate the determinant for 3 by 3 matrix. 1 minute. This is the 3 by 3 matrix. How to calculate and what is the determinant? ఎలా వస్తుంది మీకు ఇక్కడ determinant? సో ఫస్ట్ మనం ఇక్కడ determinant ని క్యాలిక్యులేట్ చేసేటప్పుడు ఏం చేయాలి?
ఫస్ట్ రో ఫస్ట్ కాలమ్ ని క్యాన్సిల్ చేయాలి మ్యామ్.
సో ఈ మొత్తాన్ని
అప్పుడు
తీసేస్తాం.
ఫస్ట్ రో
దెన్ దిస్ ఇస్ AD minus BC. ఓకే, ఇది AD minus BC అవుతుంది. సేమ్ వే ఇక్కడ తీసుకునేటప్పుడు ఏం చేస్తాం? 5 ఇంటూ వేస్తాంలేండి ఇక్కడ తీసుకునేటప్పుడు. ఈ రో ఈ కాలమ్ ని తీసేస్తాం. దిస్ వాల్యూ ఈస్ టేకెన్ యాజ్ A, దిస్ ఈస్ టేకెన్ యాజ్ D, దిస్ ఈస్ B, దిస్ ఈస్ C. అంతేనా? ఈ 1 ప్లేస్ లో క్యాలిక్యులేట్ చేసేటప్పుడు ఫస్ట్ రో థర్డ్ కాలమ్ వదిలేస్తాం. 3 ఈజ్ A, B, C, D. ఇక్కడ ఇచ్చాం చూడండి. దిస్ ఇస్ ద థర్డ్, ఇట్ ఈస్ సెకండ్ వన్, ఇట్ ఈస్ ఫస్ట్ వన్. AD minus BC, AD minus BC. ఓకేనా? క్యాలిక్యులేట్ చేయండి ఒకసారి వాల్యూస్, డిటర్మినెంట్ వాల్యూస్ ఒకసారి క్యాలిక్యులేట్ చేయండి. ఎంత వస్తుందో చెప్పండి ఆన్సర్ నాకు.
-65 వస్తుంది మ్యామ్.
ఎంత వస్తుంది?
-65.
-65 ఎందుకు వస్తుంది? మధ్యలో నెగటివ్ వాల్యూస్ ఉన్నాయి కదా. ఫస్ట్ ఎంత? 5 ఇంటూ
4 మ్యామ్.
5 ఇంటూ 0 ప్లస్ 4 అంటే 4. సెకండ్ది 2 ఇంటూ
24 ప్లస్ 2.
24 ప్లస్ 2 నా? 2 ఇంటూ
18 మ్యామ్. 18.
AD మైనస్ BC అమ్మా. 18 మైనస్ 8 ఎంత వస్తుంది? 18 మైనస్ 8 ఎంత వస్తుంది? AD మైనస్ BC ఫార్ములా. సో A వాల్యూ ఈజ్ 18 మైనస్ -8. 10 ఏంటి?
18 minus 8, 10.
18 plus 8 man 26.
కాదమ్మా, 18 minus BC. Here B value is negative value. That's why we will get -8. Here minus into minus plus. 18 plus 8, 26. అంతేనా?
Yes ma'am.
That is 52. 2 into 26. 52. Then what is the third value? Third value ఏంటి? 1 into AD minus BC.
3 minus
3 1s 3. ఇది మొత్తం 0. అంటే
-1 మేడం.
ఫస్ట్ వాల్యూ ఎంత వచ్చింది మనకి? 20. సో ఈ పార్ట్ వరకు 20 వచ్చింది. నెక్స్ట్ పార్ట్ ఎంత వచ్చింది? 52 వచ్చింది. థర్డ్ పార్ట్ 3.
+3.
అంతేనా? 3 నేనా వచ్చింది?
Yes, ma'am.
ఓకే, మొత్తం ఎంత వస్తుంది అప్పుడు?
75.
-25. -25.
అట్లా కాదమ్మా, 1 ప్లస్ 1 మైనస్ చేయాలి. ఫస్ట్ ది ప్లస్,
-25
తర్వాతది మైనస్, మళ్ళీ ప్లస్, అగైన్ మైనస్, ప్లస్ అండ్ సో ఆన్. సో హియర్ 20 minus 52 plus 3 ఎంత వస్తుంది?
-25.
-25. This is the answer. Okay, ఇక్కడ మనకి చూడండి, -1 to the power of 2, then -1 whole cube, then -1 whole to the power of 4. So whenever you will get multiplied with minus value, then we will get minus. So -1 whole cube, the value is -1. -1 to the power of 4, it will get positive value. So alternatively we will start with plus, alternatively we will move to addition and subtraction. So first one plus symbol, again minus, then plus, then minus and so on. So this problem is occurs only in size is other than 2/2. 2/2 directly we will calculate AD minus BC. In a single step we will get the answer. Other than 2/2, either 3/3 or 4/4 or 5/5, whatever it may be, then this is the procedure. The first value is plus and the second value is subtracted from the plus, third value is added, fourth value is subtracted, fifth value is added and so on. This is the calculation part of the determinant calculation. Okay namma, clear?
Yes, ma'am. Clear, ma'am.
Okay, next one, inverses. So here also two inverses are there. One is additive inverse and another one is multiplicative inverse. So what are the formulas of additive inverse? In general case, a plus b is plus b mod n is equal to 0. Leda a plus b is congruent modulo to 0 mod n. This is the formula for general additive inverse. So here the formula for additive inverse is a plus minus a is equal to 0. Here the 0 means additive matrix. Additive matrix. A matrix which contains all the zeros as its elements is said to be additive matrix. A matrix contains zeros and ones and all the diagonal position are 1 and upper and lower triangles are zeros. Then that matrix is said to be identity matrix. So here in case of matrices inverses, the formula for additive inverse is a minus a is equal to 0. That is additive inverse. Okay, clear amma the additive inverse formula? In case of sets, this is the formula for inverses. In case of matrices, this is the formula. Whenever a minus a is equal to 0, that is the additive inverse. So next one is the multiplicative inverses. Here while calculating multiplicative inverses, some conditions are there. The first condition is only for the square matrices are having multiplicative inverse. So square matrices మాత్రమే మనం multiplicative inverse ని calculate చేయగలం. That is the first condition. First condition is multiplicative inverse is calculated for square matrices only. So the second condition is the multiplicative inverse of a square matrix A and a square matrix B. So while multiplying A by B and B by A, we will get an identity matrix. Identity matrix means all the elements are zeros and ones, diagonal elements are 1, upper and lower elements are 0. So multiplicative inverse is defined as A inverse. A inverse. So before going to calculate multiplicative inverse, first we will calculate the elements. So first we will calculate the elements or to check whether the given matrix is having a multiplicative inverse matrix or not. So before going to calculate A inverse, we are going to check whether it is having a multiplicative inverse or not. So adela telustundi manaki ante. So here what is the determinant? First calculate the determinant value. This is the given matrix. First calculate the determinant value. So here the determinant value is 21. So what is the value of n? So here the n value is, we will take it as Z26. So 26 is the n value. So whenever we are going to calculate the GCD value of the determinant and n, we will get 1. Then only the A matrix will have multiplicative inverse, that is A inverse. So if we will not get the value 1 as GCD value, then there is no multiplicative inverse for A. We don't want to calculate that inverse value. Inverse value ni manam calculate cheyalsina avasaram ledu. Only whenever you will get the value of GCD of determinant of the original matrix and n is 1, then only the multiplicative inverse value is existed. Otherwise we are not able to calculate the inverse value. So here GCD of 21, 26. ఎలా క్యాలిక్యులేట్ చేస్తాం? GCD of 21, 26. ఫార్ములా ఏంటి? GCD of A, B is equal to GCD of B, R. So here GCD of A, B. This is the A and this is the B. So GCD of B is 26. R is equal to 21 by 26. That is 21. Okay, next step. GCD of 21, ఎంత వస్తుంది? What is the value of remainder? Remainder.
1.
1.
I mean 5 answer, ma'am.
5. మీరు అప్పుడే ఆన్సర్కి వెళ్ళిపోతే మిగతా వాళ్ళకి కావాలి కదా. నెక్స్ట్ వన్ GCD ఆఫ్ B వాల్యూ ఇటు వచ్చేస్తుంది 5, 1. రిమైండర్ 4 ఎందుకు వస్తుంది? 21 is divided by 5. Quotient వద్దు మనకి. In modular arithmetic we are only concentrated on remainder values. That is the first point మనం క్లాస్ లో చెప్పుకుంది. ఇక్కడ ఎక్కడ కూడా కోషియంట్స్ ని యూజ్ చెయ్యం. సో 1. సో దెన్ GCD ఆఫ్ 1, what is the remainder? 1, 5 is 5, 0. So here there is another formula. GCD of A, 0 is equal to A. So here A is 0, A is 1 and another one is 0. That's why the final answer is 1. So whenever you got the value GCD of determinant of A and n, this value should be 1. Then only the multiplicative inverse is existed. Then only we are going to calculate the multiplicative inverse, that is A inverse. Inverse value ni మనం అప్పుడు మాత్రమే క్యాలిక్యులేట్ చేస్తాం. ఓకే, ఒకవేళ ఇక్కడ other than 1 any number we will get when calculating the GCD value, then we are not able to calculate, we are not go for calculating inverse value. So this is the concept of calculating inverses. For additive inverses of matrices there is no formula, there is no checking. A minus A is equal to 0, then additive inverse. So here for multiplicative inverse of matrices, first we will check whether it is compatible or not. How it is possible means, first calculate the GCD value of determinant value with n. So we already know what is determinant and how to calculate the determinant. First calculate determinant value. After that the determinant value and n value, the GCD of determinant value and n value should be calculated. Whenever the value get 1, then only we will calculate the inverse of that matrix. Okay, this is the multiplicative inverse. Okay ma, next we will continue in next class. Okay, 1 minute, నాకు అటెండెన్స్ ఒకసారి. సిఆర్స్ ఇద్దరు ఉన్నారా?
Yes, ma'am. D section.
ఓకే, ఎవరి క్లాస్ వాళ్ళు ఒకసారి నాకు